Hey, what's up guys? Welcome to my stream. So lots of stuff has happened since last stream. So just as a little refresher, this is even build. Huh, shouldn't have shown that. Okay, so I wanted to let me see if I can just check out where we were last time. So I actually kept working on the emulator since last stream because it's kind of fun to do some shader stuff. So I think this is where we were. This rendering with shader pipeline works commit here. What's this? Hey Alvaro, how's it going? Okay, so let's build this. So last stream we continued working on bringing in the shader code from the sample that I had modified into the emulator and actually got it working. Oh yeah, I know exactly why this is happening. So actually, you know what I'm gonna do? Give me a second. All right, it's here somewhere. Alvaro says he's feeling tired. You know what? I'm feeling tired too, actually. So I don't know how long I'm gonna last. This did not work. Okay. We'll get there. All right. No, still not happy. I don't know if I should bother with this. Let me see. I know what's happening. I'm just not sure if I should waste my time fixing it. All right, let's see. Let's see if I do this. Okay, this should work. What? Oh, okay. My remove command was not working. Oh, okay, there we go. That makes some sense. All right, now will it build? Okay, it built. All right, so this is basically what we got done last weekend. Last week. I'll even plug in my gamepad. So this is being rendered with some shaders. In fact, we can see the output here, compiled a few shaders here, draw vectors, darken texture, and draw texture here. And so that's what it gives. It basically resembles a CRT screen a lot more than what I had before. And now it's a bit maybe too much of this kind of fading effect there that we have, but it's like not as flickery, and it has like a little bit of a kind of a darkening flicker that is reminiscent of an actual CRT, so that's kind of neat. I find it looks pretty good, right? So I was very happy about getting this working. So yeah, so that's basically the state of where things were at the end of the last stream. I'll stop that. Okay, so now what have I done since then? Bunch of stuff. So we were here. So after that, like, I decided to clean up some stuff. So the next thing I worked on was this cleaning up the mess around passing screen versus window size. So I think it was Kluwash who was on last stream, and at one point I was talking about there was some confusion around the fact that I had this screen dimensions versus window dimensions. I mean, it made sense in my head, but in the end I decided to just kind of clean that up. So and it was actually it turned out to be quite nice. I no longer pass the screen width or height to initialize. Like this concept of the screen size, it has been renamed to Vectrex screen width and Vectrex screen height here. So that's a 256 by 256, and this is basically what's used to compute the projection matrix, just so that we get the right projection dimension. So like if we look for that, it's here where I build an orthographic projection using the actual screen width and screen height of the Vectrex screen. Now that's it. The rest of it just uses window size, and that's basically whatever window size we choose. And the idea there is to make sure that we keep the right proportions and map them to the screen size. So yeah, I mean, it's not super interesting to look at the diffs here. It's just a lot of moving things around, and I think I may have, I got rid of this screen height, screen width stuff. We only have window width and window height. So just a little refactoring there. Not too interesting. So this was a bit more interesting. I worked on a little RAI wrapper around GL resources. I think I'll show that because I think it was kind of interesting. So basically it looks like this. You know what I'm gonna do is I'm gonna check it out. Check out. I think it's easier to see it in Visual Studio than inside a diff. So basically it's like, you know how there's unique pointer in C++11, they introduced unique pointer. And in fact, I would have liked to have used unique pointer, but the problem with unique pointer is it's great for managing resources that actually are pointers, right? Hence the name. But resources like GL resources, OpenGL, they're all basically integers. Like any resource that is represented by a handle, by some kind of opaque handle, or a handle that is not a pointer, it's not suitable for a unique pointer, as far as I can tell. I think there are some ways you can work around it. I think you can create some kind of wrapper struct, and you can type def pointer to be an integer. But there's some weirdness around it, like invoking operator arrow and stuff like that. So, and I think there's a proposal actually for C++20 to add some kind of generic wrapper that's similar to unique pointer, but that would be useful for any kind of thing. I think it even detects whether it is a pointer or not and adds layers to it, like through some kind of policy. Anyway, so this is what I wrote, and it's really simple. It's just called GL resource. You feed it a delete function, and so that's kind of the key to this thing. When you create a resource, you usually have some kind of create function, and after that you would like to be able to have it automatically delete it or destroy it. And so what I do here is that a GL uint is what represents the ID, and I store a delete function. You can create the resource. If you just have a default constructor, it's an invalid resource. Otherwise, you construct it with an ID and a delete function, and then when it just gets destructed, it checks if it has a valid ID, it calls the delete function, and then, although this is not necessary, sets the ID into invalid. And then here, I disable copy. So this is like unique pointer. You can't actually copy these resources. You have to move them. So that's what this is here. So I enabled the move constructors, and I implemented them correctly here. I think so, anyway. So yeah, I grabbed the ID and the delete function, and I set the right-hand side to be invalid. So this is basically what move is. Similarly here for the move assignment operator. Actually, what did I do here? Oh yes, this move assignment operator is different because it's move assignment. Yeah, this is kind of tricky, but what I do is I swap. I don't know if that's really the right thing to do. Probably not. But what I did is the thing that's coming in that's being moved from ends up being the container for the current version's ID. So the idea is that when that thing is destroyed, it will clean up my old resource. Yeah, I'm not sure if that's really the right way to do this, but anyway, it works. And then like unique pointer, you can use get, but this time instead of returning a pointer, it returns the actual handle. It does assert that the handle is valid here. And similarly, you can use operator star to dereference, which also returns the ID. So there's no arrow operator because it's not actually a pointer. Although maybe then it's questionable whether there should be a dereferencing operator on this. I do make use of it, so I find it convenient. It's like less typing, but maybe it's a bit of an abuse of the operator. I don't know. Anyway, the way it works then is that I have a bunch of functions now to make it nice to create, say, texture resources, where you just say make texture resource, and what this guy does is it calls GL gen textures, and it creates one, and then it returns a GL resource based on this deleter here, this local defined deleter here, that just makes sure to call GL delete textures. So that's the deleter that we add to the GL resource, and that's the make here. And then one thing that's kind of weird but works is this is an C++ 14, auto-deduced return type. So I don't name this type here. And the reason I don't name it is because deleter is a local type. It's not a type that it's not nameable from the outside. I think they call that Voldemort types because they cannot be named. So because of that, with C++ 14, we can still do this, and it returns a type here. But to give it a name, I do this. I say using texture resource equals to decl type, and then I say, give me the declaration type of if I had called this function, what it would return, and give that this name. And so now I can actually write texture resource when I want to store one, and I can call make texture resource to assign to that variable. So kind of strange, because if you call this, the return type does not show texture resource. Instead, it says here, you can see the tooltip, GL resource of deleter. The unnamed here is just a namespace, but yeah, it's just saying it's some GL resources, a resource of some deleter that you can't even name. So there you go. So similarly, I have make vertex array resource, make frame buffer resource, make buffer resource. Each one of these calls make sure to pair the right pairing of functions from OpenGL. And then after that, you can see my usage of it, like let's say we go look somewhere below, or actually we should go, I guess, with the declaration. So here we have a bunch of resources: a vertex array resource, frame buffer resource, two texture resources. And so now what's nice is, like the texture one here, yeah, this is part of the reason why I want to do this, is that if you call set viewport and change the window width or window height, which I actually don't even support yet, but if I allow the window to be resized, this would get called. Well, then I need to recreate these textures, because I decided to make them match the resolution of the window, so that we get no blurring artifacts. So yeah, so basically you can see here I just say make texture resource and assign it. And what's interesting here is that this will call the move assignment operator. Yes, like, sorry, this will call the move assignment operator, and it'll do the right thing. And then after that, you can see here I make use of it in allocate texture. I dereference it to get the ID. So all the functions afterwards just use the internal ID, just regular OpenGL functions. Here I just had a little helper to do the kind of binding and setting up the texture, but you see it just works with a texture ID. So it's not a big deal. I didn't go and like make a complete like C++ wrapper around an OpenGL texture, an OpenGL frame buffer, and all that. And I know that people have done that. There are C++ libraries for it, but you know, for my usage here, I don't think it's necessary. The only thing I wanted to manage was I didn't want to have to manage the creation and deletion of these resources, because it's annoying to have to do it. The rest is just, you know, straight up function calls to OpenGL, so there's nothing really to worry about there. You know, so it's a nice little RAI class, and like I said, maybe there's a way to do it with unique pointer, but this was simple enough and interesting enough for me to write myself. So that was fun. So after that, I merged it back into master, little fixes. Oh yeah, so this was really cool. I think I mentioned this last stream. I wanted to start looking. So I mean, at this point, you know, we were using SDL2, glue, and GLM, like as external dependencies, which is already 3. And on Windows, like, this is like no big deal. On Linux or Mac OS X, I believe, you can just use package managers to download what you need. Like you can get actually like pre-built binaries for most of these, and they get installed into well-known directories, so that, you know, your compilation environment and link environment finds everything you need. No problem, right? If you use CMake and you say find package, I think it is. Yeah, find package on those platforms, it works really well. On Windows, it's really a lot more painful. Like, I have to go and manually download and extract, and I can show you actually how I did that. You know, for example, I have here some extracted version of SDL2, and I have here, I'll open it in Explorer here. So you'll see I have glue over here, I have GLM over here, and I have SDL2 over here. Okay, and then I have like instructions for myself, because I forget about having to set the SDL2 environment variable to point to the root. And for glue, we want to pass glue root directory And in this case, I say use static libs because there's this thing about static libs versus dynamic libs. DLLs are static on Windows. And that exists on other platforms, but it's a bit more annoying on Windows. And because like on other platforms, if there is a dynamic library, that too will be installed. If you install the binary, it'll install the dynamic libraries where they're visible. Whereas on Windows, not necessarily. So you have to kind of think about, do I copy these DLLs or not? And then I have to have like these weird passes below where it's like, oh, add a post build step to copy the SDL2 DLL to the output directory. So this is the kind of annoying stuff I deal with on Windows. And why am I saying all this? So these are 3 dependencies, and I knew that I wanted to look into adding more. Specifically, I started looking at overlays. So the overlays on the Vectrex is that plastic screen that you would put in the front of the black and white monitor so that you'd get some color in your games. Now, I looked online, I downloaded some zip file that contained a bunch of overlays. Yeah, they're right here. And these are what the overlays look like. And they're all PNGs. So I was like, okay, let me look at how to, that's kind of cool, how to download, how to load up PNGs in code. And of course, there's libpng, and libpng depends on zlib. So I was like, oh great, 2 more packages for me to download and set up into my CMake. And I'm like, that's 5, and that's annoying, right? So finally, I looked at vcpkg. See if I can find that here. Just close a bunch of things here. Here, vcpkg. So what is vcpkg? It's actually an open source tool from Microsoft. So it's on their GitHub repo. So if you're a C++ developer on Windows and you're doing open source or projects like I'm doing here, you definitely want to check out vcpkg. I have to say, I wish I would have checked this out sooner because it works great. And what it is it's kind of like the equivalent of these kind of package managing tools on these other operating systems, like on Linux and on different distributions. I think there's like Pacman and what's the one the Debian one, the Debian pack. I don't know why the name is escaping me, but oh, that's it, apt, advanced packaging tool. So that's it. Like you have apt apt with apt-get and all that. You have Pacman, and you have a few. I think the one Homebrew is the one I think people on OS X use. So that's great, right? So vcpkg basically gives you that for Windows, and it's like super trivial. Like you just clone this repo, you run this bootstrap batch file, which then goes and like builds it all and all that. It finds your Visual Studio, builds it, and it provides this one. It builds this one executable. So I'll show you a little bit like what that looks like. So I downloaded it here, vcpkg. So I'll just open here, vcpkg. So this is the Git, the Git repo. I ran the bootstrap here, and it ended up building this exe, vcpkg. So if you open a command prompt, oops, wrong. No, not this. vcpkg. And it's this nice little simple command line tool. So you can say vcpkg search for package available to be built. So if I do, like, say search vcpkg search, and you search for SDL2, and it gives you a bunch of hits, right? You have SDL2 itself, graphics, image, mixer, net, TTF, and what they are. And it tells you if your library is not listed, you can actually open an issue, or do it yourself, like package it up. But if you open an issue on their issues for the project, they're gonna try and get that done for you. So I don't know how many packages there are, but the ones I needed were all there, so that's kind of fun, right? I needed SDL2, I needed glue, I needed GLM, right? And then I needed, was it libpng, was it? Yeah, there's libpng, and which actually pulls that zlib in there. And actually, just earlier, I was thinking about how I'm gonna want to probably have some like imGUI. I was thinking of using imGUI to put some, you know, dialogues and stuff like that, maybe some little tweaking things, just to like get a very simple GUI thing going without having to mess around with frame borders and menus and all that. So and they have a version here of imGUI, so that's kind of cool. And so you have that, right? And so I went ahead and, you know, you can read the documentation, but what's really cool is they also manage for you the whole idea of what it does is it doesn't download pre-built binaries. It downloads the source code and then it builds them for you. And it also handles building dynamic versions, static versions, like static libs, dynamic libs. It handles building for x86 or x64. And you can basically define what you need through this thing they call the triplet. So I'll show you a little bit what that looks like here. So here. So like the triplet is basically the name of the library, then, no, sorry, that's not it. It's this here. It's the architecture, so x86 or x64, the platform, so it's Windows. I think the other platforms you have are like UWP, and then static or dynamic. So Alvaro asks, do you know if it's possible to have a private depots with vcpkg? Yes, I believe you can. I think you can actually create, you can download it, you can create your own packages, then serve it yourself. There's no requirement. Like if you want to pull the stuff from their servers, that's supported. But if you want to provide your own with your own packages, that should work as well. And also what's really interesting is, so if I said earlier, it's not downloading pre-built binaries, right? What that means is that everybody has to build all these libraries, right? Which, is actually kind of a good thing, I think, because if you upgrade your compiler or whatever, it ends up updating all your third parties that you've downloaded, which is good. But of course, it means a lot of time wasted, maybe for if you have 30 people on your team, you don't want to have everyone building all the third parties. So you can download it, build everything, and then there's like a vcpkg export command. I think we can see it here. Export. So it exports a package, and it's not written here, but if you read the documentation, what it says is that it takes basically kind of like the structure of vcpkg and just the pre-built binaries that you've built, and it puts them somewhere else. And then after that, you can decide how to serve that to your team. Maybe check it into your source control if you have one, or put it on a network drive, and then you have everything built. So you don't have to make everyone pay the cost of going through this. So I think that's pretty neat. So in my case, I went ahead and installed. I think you can do vcpkg install, list, to see what I've got. So here you can see I've got glue, and I built the Windows static versions of these. I tried with the dynamic, it totally worked as well. So static, glue, GLM, SDL, and zlib and libpng, because that's something I worked on later. So I have all these here, right? And then what's nice is how to do it with CMake is it's really trivial. Once you've got that done, which takes no time at all, go to, actually I'll go to Visual Studio here. So yeah, so basically, okay, yeah, I still have the old command line because I didn't check this out, but oh, here it is. So then if we look at the diff here of the README, this ugly command line that I used to have becomes really simple. You just tell CMake to use this. You can tell it what CMake toolchain file to use, which is a CMake file, and you just point it at this vcpkg build systems vcpkg.cmake. So that's their own toolchain file. So if you tell CMake to use that, it will be able to consume and find all the libraries when you do your find package. And you can also tell it, this is like an argument that is used by it's set up in the environment for CMake, and then this vcpkg CMake will look at this, and that's where you define your triplet. So x86 Windows static. So it's saying I want those, right? So Alvaro says that's super interesting. VC package looks like a powerful tool. Yeah, I'm talking about it because I'm actually really happy to finally have something like this on Windows, because this has always been a sticking point. Like, you know, I mean, I come from video games where, you know, what we tend to do is just take all third parties and just check them into source control, right? And I mean, that's fine when you're working in a corporate environment and you have, you know, an internal repo where you can just keep all your binaries and everything. But for open source, it really sucks, right? Like, that's just not what you want to do. You don't want to like be checking in all these third parties in your repository, because that's just a lot of data, and it's not good for users, and you know, you're duplicating stuff that people may already have, and it's just not done on the other platforms. It was always kind of a Windowsy thing to do. So since I want, you know, Vectrexy and my other projects to be cross-platform, I was always looking for the right way to do it for all targets. And I think this is finally the solution that we were missing for Windows that makes it like the other OSs, the other two anyway, flavors of Linux and OS X. So a lot of stuff to say there, but yeah, so I did that. And after that, and by the way, this is why I was having trouble compiling earlier when I went back in time, because I was still trying to use my VC package libs, but it wasn't quite working, because in the older version I had a dependency on SDL2 that was actually, why wasn't it working? Oh yeah, there was just some stuff about like extra libs that you have to add for Windows. If you try to use the SDL2, that's it. If you use the SDL2 static library, you have to add extra libs that you link against, which are here, these three here. And that's just because if you use the DLL, these are already pre-linked into the DLL and you don't have to worry about it. But if you use the static version of SDL2 on Windows, you kind of need, it depends on these three libraries, so you don't kind of get them for free. You know, that's just typical kind of static lib problem. I mean, if SDL2 had its own CMake thing that said which things it required, these would have been brought in automatically, but it doesn't seem to have that. So anyway, this is just me removing pre-render function because we don't need this anymore. What was this again? Oh, I just did some refactoring of that load shaders function. Not super interesting, just a little bit of cleanup on there. So okay, add a comment. Add set vertex buffer data overload for arrays. Okay. Yeah, I just cleaned something up here so I could reuse set vertex buffer data. Then remove old display drawline. Oh yeah, so this was a function that was not being used anymore, because now we're using the new display, the new draw lines on the display where we pass it a vector of lines. So the old one where I was actually drawing one line at a time was currently unused, so I just deleted it. And then, so this was I think just a couple days ago, although I rewrote here. Anyway, I started working on adding overlay support. So that's what I was saying earlier, is that I needed to add a dependency on libpng. So that was super simple. Now that I'm using VC package, I just added that. And so libpng actually depends on zlib, so it automatically pulls that in. When you do a find package on png, it actually also finds zlib, pulls that all in. I end up with these 5 dependencies, but super simple, right? You can see here the diff is no big deal. And yeah, I just added libpng to my list of things to do through VC package. Okay, so yeah, so this is interesting. So let's check this out. What do I have? All right, check out branch overlays. Don't change. Okay, and let's. Oh, sorry, wrong folder. Okay, now we're going to use the CMake line. Here we go. This is the CMake line that uses the vcpkg toolchain. Or vcpkg, yeah, the toolchain file from vcpkg. So this is a work in progress, as you can see here. I just kind of hacked something together just to see if it would work, and it did. So that's what I'm going to show you guys now. You actually may have caught a sneak peek if you were there earlier. I don't know if Alvaro, you saw it, but it's kind of cool. So I have here, like I said, there's a bunch of overlays. So I just extracted all of them into a folder called overlays, and there they are. And in GL render, what I did, okay, so this is very much work in progress, as I was saying. So here we have this, I included png.h here, and this is some code that I found online for how to load a PNG image and then get it into a texture. But man, I have to say, like, libpng is super old, and all the code I find online for how to load through this API is kind of gross. It's not so much the C nature of it, which that's fine, but it's like it's got stuff like set jump here, which I had to disable a warning because set jump doesn't play nice with destructors in C++. So that's the kind of thing I don't really like. And apparently there are ways around this, but I haven't found people doing it, and I didn't feel like wasting my time looking into it. But like it says here, set error handling if you are using the set jump long jump method. This is the normal method of doing things with libpng. Required unless you set up your own error handlers in the png create read struct earlier, which is up here. And it's these null parameters. You can say, here's a pointer to my error handling function, and a few other ones here, warning function and all that. So I suspect that if I went ahead and hooked those up properly, it would work. Otherwise, you let it do its own thing here, and it kind of works. So honestly, I don't care too much, right? Like, as long as I can tell whether or not it succeeded or failed. So that's it. See, if it ever reaches inside here, it's going to return false. So if it fails to load, we'll get return false, otherwise returns true. So that's the loading of the PNG right there. And then we have this load PNG texture. So actually this code too came from the same page where I found the other one, and there was actually a bug in there, which I was happy to say that in order to figure it out, I actually went ahead and installed RenderDoc and used RenderDoc. I'd never really used it before, but it's a great tool, really. I think Kluwash had mentioned it last week, and I'd already kind of looked at it. But yeah, here you can see this is RenderDoc, and you can kind of see, like, what it does. It basically gives you can take snapshots and stuff. I might show it a little bit later, but anyway, so that was cool. I used that to figure out my bug and fix it. So here's the kind of hacky stuff I did. I added a new texture resource called goverlayTexture, which is fine. That's not the hack. In initialize, I create one, and then I have here just a couple of load PNGs to try different ones. So I'm loading the one from Mindstorm. So that looks like this. So that's the Mindstorm overlay. And strangely enough, there's like a few different Mindstorm overlays in this folder. So I don't know how this zip file was put together, but and I don't think this is complete because there's only like a handful in here. So I'm gonna have to find a way to just kind of download all of them, but whatever. So I do this, and then, oh yeah, and this is GL object label function where you can give names to resources. That's kind of cool because then these names are what show up in RenderDoc. So that's why I did this. I have a few of these now where I named my textures. Okay, so that's the overlay texture. And then, oh, here we go. In the third pass where I render to the screen, I now bind, apart from just binding the rendered texture that's got like the darkened version of the screen of vectors, in texture slot 0. In the slot 1, we bind this overlay texture. And I also set an overlay alpha here that we can play with, so I'll show you how that works. And then I modified the shader. What's it called again? It's called draw texture. Yeah. So there's the original sampler for the render texture, then there's the one for the overlay texture and the overlay alpha. And basically what I just do is I sample the two textures, get their colors, and then I use the alpha channel from the overlay, because the overlay has alpha in it. So like, we don't see it here, but I think if I open it in Paint, do I have Paint? Or I have Photoshop anyway. Anyways, whatever, it's got an alpha channel. And so I grab that alpha channel here, and then I just do this thing where I say, take the alpha channel minus 1 minus the overlay alpha. So that means that you can pass in a overlay alpha of 1 and you get the full alpha of what's in the channel. Otherwise, you can say 0.5 and it reduces it and whatever. So yeah, it's not quite right. I probably have to clamp it and stuff like that, but whatever. It's just me trying stuff out. And then I do a linear interpolation of the original texture with the other one above it. Sorry, just getting a little hot. Okay. So let me show you what that looks like. All right, there we go. So this is the emulator running with the overlay. So a few things to notice is it's a little bit hard to see what's going on underneath, right? Like, I'll actually play a little bit. Okay, here it's fine when it's big. I mean, you do see, but definitely like it's not as clear to me anyway. You know, there's the kind of there is the bluish tint, which is nice, and you've got those lines and all that, and it's cool. But what it tells me is that, and if I look at the real Vectrex or videos of it, that there's a bit of a glow, or a lot of a glow actually, that's missing. So I need to add a glow effect to the basically that, you know, the image that we draw and then we darken. I need to add a pass in between there where we draw all the vectors and then we do kind of like a glow, you know. So I'm not sure what that is yet. I was kind of reading about how to do glow, and it's basically some kind of what do you call that? Like a bloom. And I mean, I think in our case it's going to be fairly simple because it's like white lines on black, right? So I read something about like kind of doing a vertical and a horizontal pass where you take, you know, the pixels and you kind of draw them along the axis at varying alphas or something. I need to reread how to do that. And so that should give like a glow, you know, like a glowing effect, and everything will look a little bit thicker. And then after that we darken that image, and I think then it'll really kind of show through with the overlay. But in the meantime, just to kind of see what it would look like, I did have this overlay alpha that I was, whoops, that's not what I wanted. I wanted to take this. So if I just show you here the overlay alpha, and GL render, here. So I have this overlay alpha that I can play with. So it's set to 1 right now. Just as an extreme, if I put, let's say 0.5, it's going to get really, really low. But so yeah, you don't really see the blue anymore, but you do see the overlay, and the whole overlay is like see-through now. And of course, the white of the image stands out a lot more because it's not being mixed with blue anymore, right? So like this is way more playable at the moment, but of course you're losing the whole blue effect of the original overlay, right? So, you know, if we can make it less strong, so come here. I think I tried like 0.9. 0.9 seemed to be decent. It kind of got us a bit of best of both worlds. You still get to see the blue the blue coming through a little bit, but not so much on the white image in the back. So this is not too bad. There are some things I was wondering about, like the score seems to be hidden by the overlay, so that makes me wonder a little bit. Like, I wonder if part of the reason for that is that actually, I'm gonna have to go look. I think what is the real case here is that the overlay is not supposed to. It's not a one-to-one mapping with the screen itself. I think that the screen itself is actually smaller and, you know, kind of curved, right? And then the overlay kind of goes around, is bigger than the screen. So, you know, I would have to adjust the screen and bring it in. I wouldn't be surprised if in fact it's quite a big amount of adjustment. I think like the score up here, I'll just bring this here. The score up here probably should be underneath the player one here, right? Actually, we could probably take a look. I keep doing this. Is this one that shows? No. So let's do Vectrex, Mindstorm. I'd like to find a decent. Yeah, I think I always keep coming to this one. So there, you can really see the overlay there. But I would like to see the top of the overlay. Looks like we don't see it here. But you can kind of see, right? Like, this is the screen inside. And you can see that it's not like all the way out to the edge here, but I'd like to see the top border. So let's see if we can find one that shows the top border. I mean, okay, we don't see it really clearly, but we do see that, like, you know, the screen is up here, right? And you can see where it says like player 1 and player 2. So there is really definitely a big difference in terms of the relative screen size. You know, the screen is supposed to be above the Mindstorm and below the score. So really what I've got going is completely wrong. You know, like, yeah, you can't even see how many ships you have left right now in my version. So that definitely I need to do some work there to bring that in. And here, you know, I was talking about the glow. You can totally see the glow. It's like massive, right? So much glow. So definitely need to do that as well. So yeah, so, you know, still very happy with this, obviously. I think it's in the right direction. Just thinking, like, probably what I just need to do as a first pass is take the window size and kind of do like a reduction and set the viewport based on this reduced value for the textures that I will render the game to, and then, you know, keep the full window size for the overlay. And I don't think I'm gonna do necessarily the warping effect, at least not now, not initially. I'm fine with keeping it simple and keeping it square. But yeah, okay, we just got an assertion here. Oh, interesting. Looks like we got an assertion because the ROM apparently tried to set the shift register mode to a different mode, but I only expect it ever to be shift out under 02 via 3033. That's interesting. So yeah, don't know what happened there. Doesn't matter. There's definitely like still bugs to iron out in the actual emulation core. There's still games that are not running, but that's okay. What I wanted to show, since we're looking at overlays, is let's just try a few different overlays. So one that I was trying out, and actually now, you know, now that I think about it, this whole like size not quite matching correctly, it's probably not going to look right for this. It'll explain why this one doesn't look right. So there's this game called Armor Attack, and Armor Attack is my emulator does play it correctly. Let's go. ROMs extracted, Armor Attack. So let's grab this version here, and let's set that as the ROM we load. Okay, so if we load Armor Attack and we use that as its overlay, you're gonna see looks pretty cool. So this one here is Armor Attack. Yeah, definitely now it'll make more sense, because these black markings on Armor Attack are supposed to line up with the quads that are going to be drawn in the game. You'll see what I mean. So like if I, so here, you know, like it doesn't quite line up. It's like this here should be above on this one. This you can see it. The general shape of this black stuff from the overlay is supposed to line up with this shape here. Yeah, actually all of it, even the outer shell is supposed to follow, because this game is really cool. It's a tank game. It's a shooting tank game. Oh, there's a helicopter and another tank. It's actually a two-player game as well. I think, oh, there we go. Actually, I have another weird bug where I can't turn my tank left for some reason. It's a Zoolander tank. Okay. It's quite a bit more challenging when you can only turn in one direction. Really gotta fix this. And I got some out of range. Looks like we're accessing invalid memory. This is the kind of bugs I'm talking about, like where games will, certain games will work and then, you know, at some point they'll crash or something. So I still have a bit of work to do there to fix all these bugs. But still, I thought that was kind of neat. So yeah, there's that. So things I'm thinking about working on. So I'll pull out my to-do list here. Sorry, thought I saw something. Okay. Oh, there we go. I can actually move this. Think about how to improve rendering. Yeah, see, I wanted to do this. Processed means something like stored in a buffer. Yeah, so we did this. So let's move this down to done. It's always fun. Yes, these are things that I know I need to do that will probably fix some of those nasty bugs we're seeing. So things that I'm thinking about. So there's the overlay versus screen size mismatch. So basically the game screen, or like the CRT screen, is smaller than the overlay. See Armor Attack for lining up buildings with overlay image. So that's what we just spoke about. What else? Yeah, so one thing I really like to do, so kind of like how I love the idea of auto configuration with emulators. So what I did, for example, for the gamepad is that, you know, you don't really configure it. So if you have no gamepad, it's the keyboard. if you plug in a gamepad, then that becomes your player 1 and keyboard is player 2. And if you plug in 2 gamepads, you get 2 players playing with gamepads, and it's all, you know, automatic. And, you know, maybe I'll need to add some configuration eventually for mapping buttons and stuff, but kind of like the defaults are pretty decent, I think. And I like that. And I would like it to be the same way for the overlays. Like, I don't want the user to have to go and select the overlay that goes with the ROM that they picked. So what I would like to do is, you know, have a way to detect which overlay goes with which game. So I still kind of need to think a little bit about that. And, you know, there's things like I was pointing out earlier, there seems to be like a lot of dupes out there. So definitely I'm not going to be using file names to figure it out, because I just don't think that's the right way. I think the right way is to take some kind of hash, some CRC of the file data to kind of like uniquely identify it for each PNG, and have a mapping of ROMs, which I also want to have a little, you know, hash database of all the ROMs that I know mapped to which overlays they go with. And so then you just pick a ROM, and I'd look and see if there's a matching overlay for it and grab it. So that's you know, just think it would be nice that it'd be automatic. You'd get the right overlay, and if you want to override it or something or set your own, you could. But if you don't, at least you get the one that goes with that game. So there's that. And then I was even thinking, like, because I found this site, Vectrex overlays. Yeah, so Vectrex World has, like, I think this is like the site where I'd need to get them all. And actually I may have gotten them from here, but it seems incomplete. I'm not quite sure. Or maybe it's just there are just so few games. I don't know. All the good things here. Armor attack. Yeah, you know what? I guess I have all of them. I just don't understand why there's so many Mindstorm ones. There's Mindstorm, Mindstorm 2, Mindstorm 3D. But see, these two just say Mindstorm GIF. I don't know why I have Mindstorm lives and bullet hacks. It feels like this zip file that I got, which came from the same site, doesn't quite match up with what we have here. So anyway, what I was thinking was, like, you know, maybe rather than have the user go and download all the overlays, maybe just like hit up this site and download them on the fly and cache them. You know, so if you try to play a game and you don't have the overlay, I try and download it for you from here. So I don't know. I don't know if that's a reality. I don't even know, like, if security-wise that's something, if that's a good idea. But I think it's kind of neat, right? To be able to do that. So, but then again, there's not that many. So I don't know. It's things I'm thinking about. So let's write those down. So mapping of game ROM to overlay image. Okay. Hash both, keep multi-map. And I don't know where I would store this necessarily. Like, ideally for me, I don't know what ideally would be. Like, I don't know if I want to have like a bunch of configuration files, or if I wanted to have this thing baked into the ROM, and into the executable. Probably it's going to be some kind of configuration, and I'd want to generate it as well. So anyway, we'll think about that when we come to it. I'll write here maybe support auto download of overlays from here with caching. So that would be interesting. Oh yeah, the other thing I really wanted to work on is glow effect. So this has nothing to do with overlays. Glow effect for the vector display. So yeah, that's pretty much what I'm thinking. And I don't know which order or what I want to work on next, to be honest. Oh yeah, so this is the site where I got the loading a PNG as a texture. It was from here. Morton Noble's blog from 7 years ago. Although he updated it 4 years ago. So yeah, that's vcpkg. So this is render doc. I was reading the documentation. So yeah. So I'm not sure if I want to get started on one of these. I was thinking about I think what maybe bang for buck, it would be cool to get the glow effect working. Or maybe to try and do maybe it's simpler to kind of get this screen size mismatch thing working. Let me see, what would I do for that? Oh, actually, what I should do is I should clean up this code a bit. Like I said, this is totally a work in progress, right? Like one thing I was thinking about was this, I had to add this disgusting warning disable. I don't like doing that kind of thing here. Interaction between set jump and C++ object destruction is non-portable. I think I can get around that if I actually make a separate C file that has this load PNG image function in it. Because this is really just a C function, and I can keep it as it is. In any case, I don't really want to keep it in here. Yeah, let's just see what happens if we add this in a C file. I'm really curious. Because then I think what happens is it invokes the C compiler, so we shouldn't have any warnings that, you know, that have to do with C++, and I wouldn't be able to add any C++ stuff to it. So that should be technically safe. I don't really know what to call it. PNG. I don't know. PNG utils or something. Because basically just wrapping a call. Okay, so let's say PNG utils.c. And we go and remove this function. Okay, so it wants GLU byte here. Don't really need that. What I need here is just a, I'll just put a, or maybe a unsigned char use like that. That should be fine. Okay, and before I add a header, I'm just gonna forward declare it in here. Strange. I wonder if it's because I need to extern see it or something. Like, why would I get this warning? No, I still get it. Why would I get this warning if I'm compiling a C function? Normally, when you compile .c files, it'll use the C compiler. I wonder if I can test out that theory. Ah. So it doesn't seem to mind that I have a class with a function in it. So it's still using the C++ compiler on the .c file. So am I wrong? Yeah, see, it says it here. By default, the Visual C++ compiler treats all files that end in .c as C source code, and all files that end in CPP as C++ source code. To force the compiler to treat all files as C regardless of the extension, use the TC compiler option. Doesn't seem to care. PNG utils. C compiler. Yeah. I wonder if it's because of this. Oh, we can pick C++ 17 now. Oh, that's kind of cool. Yeah, because this comes from a recent update to Visual Studio, where not too long ago I had to put C++ latest to get the most of the C++ 17 features, but now that they actually expose C++ 17, because I guess they support it either completely or nearly completely. That's kind of cool. But I'm not seeing how to make it really compile it as C files. Everyone just says call it a .c file. Oh, no, I'm getting errors in there as well about malloc and memcopy. So I think that's memory. Yeah. So strange. I wonder if this is... It looks like a kind of warning that they would emit even in a C project. But then again, I shouldn't be able to create templates and instantiate types that have nothing to do with C++ in here, right? So that's super weird. I shouldn't be able to use, for example, operator new. You can verify you're using C with this trick. In C prints 4 and C++ prints 1. Why? Is the problem is the size of a character constants. In C prints 4 and C++ prints 1. Really? Okay, let's get rid of this warning just to see. I'm really curious now. Unresolved external symbol. All right, probably the extern C. Actually, one. So that's C++, ostensibly. So, no idea. Anybody else know? Anybody know why it's not building C files when I make it a .c file? It says it here. The Visual C++ compiler uses a simple rule to determine which language to use when it compiles your code. By default, the Visual C++ compiler treats all files that end in .c as C source code and all files that end in .cpp as C++ source code. To force the compiler to treat all files as C regardless of file name extension, use the TC compiler option. Kind of disturbing that this doesn't work as expected. Let's see if I can open the VS 2017 build command prompt. error syntax. C student. Okay, so here it definitely is behaving differently. It's actually finding stud from C student. Is it memory? Is it memory.h or something that I have to include? Core CRT. All right, so that worked for that. Now I can't find PNG. Aha! Ah, there we go. That's a bit more interesting. So actually it's not memory that malloc comes from, right? It's like stdlib, if I recall. It's like standard lib. Yeah, standard lib. And memcopy comes from string.h. You know, I started in C many years ago after learning Pascal. Okay, so it's still compiling though, as though it were. I still think it's not doing the right thing. When I do it from the command line, it definitely doesn't like what it sees. See, it says it doesn't know what this template declaration is right here. But when I build within Visual Studio, it's not doing the right thing. Maybe it's, no, I was gonna say maybe it's CMake, but I don't think so. CMake just generates the Visual Studio project. Yeah, really don't understand. Maybe it's the fact that I'm saying stud C++ latest. Maybe this here is kind of like having this overriding effect. Let's try. If I go to advanced, no, all options. Oh, here, compile as. Why would it say that? If I say default, it'll probably do the right thing. Yeah, there we go. Is it because I added it myself as a .c file? Or maybe it really is the way CMake generates this project that causes it to do that. Do I have a string in here? Syntax error string. Where's string? Is it this? Oh, it doesn't like the external C if I'm in C. Okay. Bool? Really? Oh, right, and we can't pass by reference. Oh man. Good old C. And doesn't like bool. Yeah, so actually bool was added to C99, so I don't know what's up with that. Looks like it's still C89 in here. I thought they had added C99 support. Yeah. Okay, so I guess it's not part of C99. You know what? I'm curious about the printf statement there. So if I do std.io.h, let's just do this. Right. Actually, you know what we'll do? Sign unsigned mismatch. Okay, it's compiled. Sweet. We're gonna have to go change our call site. Change this to pass in the pointers. Wow, yeah, totally does print 4. Interesting. Okay, and it still works. And in this case, I don't need to have that warning anymore. I can go take it off from base.h here. Let's make sure of that. So I do all this, but I'm not sure this is what I want. Yeah, it builds. I mean, it builds and it works. That's cool. But yeah, not super happy with it. I think what I'm gonna do. Let me undo all this crap. Let's bring it back to being a C library. I mean C++. Okay, this is what we'll do. So we'll rename this something like image file utils or something. And I think I'm gonna do just a kind of pragma warning disabled thing, like scoped based maybe. Or you know what, whatever. Just leave that here for now. Yeah, so I think tonight I'm just gonna clean up this code and then we'll do something more interesting in a couple nights. Okay. So I want to add a header for this. I feel like giving this a better interface. Just for fun. Like something like this where we have the width, the height, whether it has alpha, and then a unique pointer to the data. And is this how you do it, or is it like this? Yeah, I think it's like that. Yeah. And then what we can do is, you know, let's C++17 this thing, and what we'll do is we'll return an optional of that. So if it succeeds, hey BD, how's it going, man? So, you know, if it succeeds, it returns a valid PNG image data. If it doesn't succeed, well, it just won't, right? And this forces us, this is what I like about optional, is that it forces us to check that it succeeded. You can't just ignore it. And so then we get rid of all of this crap here. And also what I did not like about the old one was that you had to pass in a pointer and you had to make sure to call free, which to me is kind of crap, right? So let's see if we can make this work. So if this fails, we just return like that. Now, of course, the warning about set jump not working with destructors is something we do need to worry a little bit about. So we don't want to rely on destructors in here. So I don't think we have to worry, because I'm not going to create any objects until, or I mean, I don't care because the destructor in here is trivial. So we should be okay. So I'll call this result. Let's see if this works. So here, this will be result.width. Height and has alpha. And now for the data, see, instead of doing this malloc here, we're going to say what is that? make unique. Is this how you do it? I'm not sure I can do a make unique for a buffer like this, right? Yeah, like it looks like you'd have to do it the old way. You can't use make unique, right? Yeah, I guess I could use vector. Should I just use vector? Right, you don't want to pay the cost of value initialization. That's true. Yeah, so I guess it's alright. So basically we'll have to, or I guess I could do reset new uint 8t of row bytes times row height. Okay, there's something. What's the problem? It's saying it does not have a member called data. $73 is an unexpected token. Line 2, position 66. I'd like to compile this file, but it's not compiling, so let me see what's going on here. Okay. Thank you, compiler. So, right, we don't have an out height, we just have a height. Let's just use that. So this becomes just not sure what's the best way to get at it. Get the pointer to it. Alright, and then finally here we return the results. Okay, so that looks good. So let's move this into the header here, and we'll move our function now. And we're gonna have to move optional. And we're gonna have to move memory. Oh, yes, and obviously include our matching header. Okay, so that looks good. So we still need this gross pragma here. Yeah. I don't really want to do it this way. I want to do like a macro that is be like pragma warning push. Like this. So like it's something like we push it, we disable it, and then we pop it at the end. Can I do that? What? Oh no, that's it. I cannot use it like that. I have to do the little oh, how is it again? I think I have something in my like that. Because you can't put like a preprocessor in the preprocessor. You have to do something like this. Pragma. Yeah, like that. I don't know why it insists on formatting it this way. Client format. Unless I put it all in one line. Yeah, let's try that. Ah, okay. Okay, so this is MSC specific. So the idea here is to go like 4611. No, not like that. Like this. And then we say, so we push warning. We do MSC push warning disable this, and then we pop it at the end here. Yeah, that works. So now I can move this into base.h. Or I should say compiler specific. I have to say, if it's not MSC, Microsoft's compiler, do nothing. Made a mistake somewhere. Oh no, I have to include base.h here. Okay, I'm resolving some little PNG reference. Yeah, so now we go back into GL render. We don't do this forward declare anymore. Instead, we include image file utils. So this code's going to be just a little bit nicer because we'll say auto PNG image info, was it, or something? PNG image data. Image file utils. Hey, thanks Himujal for the follow. Appreciate it. Alright, so now we say we want to load the file like this, right? And we'll say, you know, if it succeeded, right? Or if we can say like if it didn't succeed, I'll just say something here. Failed to load PNG file. Like that. And we'll return false here. And if it did succeed, I don't need any of this garbage anymore. I won't need this free at the end. Oh, actually I did have a unable to load PNG file already. Okay, whatever. All this is gone. So if we wanted to just keep the same semantics, we'd just do this, right? We'd say height, width, and has alpha. Oh no, that's it. Since it's an optional, we can use the arrow operator, right? Is that right? I guess no, because you don't treat it like a pointer, right? I always forget how optional works. Does it work? I think it does work that way. Yeah. Yeah, it totally works. Okay. And then here, That's alpha, and here we grab our data dot get. Or, in fact, couldn't I just dereference it? Maybe data, maybe get is fine. Right, this width and height. And has alpha. Yeah, okay. So let's see if this works. Works. So I think that's a lot nicer. In fact, the only thing I would do now, it's kind of funny to do this, but since we're like, I don't know. Oh, I called it PMG. Maybe I'll just call it like image data or something. Just keep it a bit shorter. And it's like here we don't have to worry about deleting the memory. As soon as this local is off the stack, it clears, it deletes the unique pointer will delete the array of bytes. So we're all clean. See, this is what I like about C++ 17. Using optional is nice. What I was gonna say earlier was like another interesting thing that you can do now since C++ 17 is you can do destructuring, right? So like all of these members here, you can, although like I don't think there's any point at this to do it right here, but like I just copied them here, but you could do like auto with height has alpha and data is equal to, and like dereference image data here. So what I just did here is I destructured a struct into each of its components. And what this is supposed to do is it's going to make each one of these, it's not showing it here, but these are supposed to become references to the fields in here. I would love for it to show. Because if I did that, right, then here, you know, instead of writing image data, I would just do this. Let's see if this actually compiles. Attempting to reference a deleted function. It wants it to access the copy constructor of image file utils PNG image data here for some reason. Cannot decompose a type containing an anonymous union or struct with. Cannot decompose a type containing an anonymous union or struct. Let me see something. So just two questions here. This is all new stuff, right? So first is like one of my questions is this how you're supposed to destructure a struct? And the other question is, does Visual Studio 2017 support it? So C++ 17 structured bindings on struct. So here's a struct S. Okay, so they just take the struct. Yeah, but in my case it's an optional, right? So I want to, okay, just as a test here. So S here is supposed to be image file utils PNG image data, yeah. Let's just be really, really obvious here. Does this work? Same idea. Binding to public data members. Every non-static data member of E must be a public direct member of E or the same unambiguous public base of E. Oh, right. The problem here is I need to put auto ref. That's why. Because data is, or not, but data is a unique pointer, right? So we don't want, yeah, no. I thought auto ref would do it because I'd get a reference to the unique pointer. The type of the element is CV. Receive is the CV qualifiers of E, and T is the declared type of the ith member. Const auto ref ABP. I think I'm like rubbing up against such a new feature here that's not quite working. I can see that I think my Clang format version doesn't know yet, I guess, how to format this in the way it normally would want to be. So okay, so it deleted copy construction because of the unique pointer. So it's saying I can't copy PNG image data, but why does it want to copy it? Yeah, that's fair. That's fair. But why does it want to copy it? I don't want to copy it. I want a reference to it. Identifier and the identifier is an L value that refers to the next member of unit declaration order. Bit fields are supported. The type of the L value is CVTI, where CV is the CV qualifiers of E. E is what? Oh, sorry, each, okay. Qualifiers of E, and TI is a declared type of the ith member. The reference type of the ith identifier is CV. The referenced type is CVTI. I don't know. To me, this should have worked. Like it would have been the same as saying, you know, to me in my mind it should be something like this was like a constant ref data is equal to s dot data. See that works, you know, and if I use data here it would work. So why is it that if I do this const auto ref, each one of these should be a constant reference to the thing that's in here? Or, yeah. Anyway. So, who knows, maybe it's Visual Studio. So let's bring it back to this. And in any case, I wouldn't use the structure bind. This is sort of what I was saying before, because then what's the point of having the struct in the first place, right? Accessing the members to the struct is perfectly fine. Okay, and actually, I'm just gonna get rid of this. Move this guy, load PNG texture. Load shaders. Where should I put this? Under here? This is when Clang fails me. Okay, whatever. If not loaded. I think I ever used Sierra. Oh yeah, I do. Failed to load overlay. Why am I even using this? All right. attack. I actually wanted to see Mindstorm. All right, let's get this committed. Oh, and I wanted to just do one more thing. I want to give credit here. I want to give credit to the author of this function. That's why I kept this tab open here. Where is it? Did I like, oh, it's this one, yeah. Function adapted from here. We're adding these two files. Okay, so I'll say here, implement overlay support. Currently, always attempts to load mine dot, what was it called again? Mine.png. So like if the file isn't there, we should get like a little warning in the error output, but it should still work. So I renamed the overlays folder. Ah, right. Yeah, there's that problem. So what we want to do there is, what do we want to do? Fill the buffer with all zeros, I suppose, would be the nice thing to do. What happens if I don't make that texture? No, I really should make one. I'm trying to think what the simplest thing is to do. Like I could literally make a tiny texture and it would work, right? I don't know what the minimum texture dimensions are. Minimum texture size. Like 16 by 16 or something? Not max. I guess no one looks for minimum. $64 by $64. That's for ES. Seems reasonable. So allocate texture, so say overlay texture here. Width and height. Oh, I don't need to do that. Okay, I can just, my function takes it. Ah, but what does it initialize it to? Oh, then I gotta do set vertex buffer data, that's it. So I do want to keep this. Oh right, it's not a buffer like that, it's actually vertices. No, that's not what I want. I guess I don't have yet a case where I load, let's see. That's what I was doing here. Pixel store I and GL text image 2D. Okay, we'll bind to the texture. Do the same thing here. So maybe we'll rewrite this one in terms of this guy here. This is very confusing what I'm doing here. This allocate texture is kind of a garbage function. And in fact, I realize here I'm making it a 32F buffer. Yeah. It's kind of a badly named function. I need to kind of consolidate. So the idea behind allocate texture is just go ahead and create one. I'm giving you a texture ID and I just want you to create some like buffer on the GPU with this given size and width, and I'm right now not specifying which type it is, but I should. And it's got some defaults there for what we usually want. Then I have this load PNG, which is kind of similar, right? And now I've got load texture data where I'm passing in data. So maybe what we want is something a bit more generic than this. It's kind of like, we'll say allocate texture. We'll say give me the format, GL int internal format. And maybe what we'll do for that is we'll just make an enum class. Do I want to do that? Because I don't really care. I can use, yeah. Yeah, let's just keep going with this. We'll say give me the internal format, and then we'll have like an optional buffer pointer for data. And so what we'll do is we'll say internal format here. I don't know about this unpack alignment business. Okay, so here we want to pass the data, what they call pixels. Okay, we'll call it pixels then. Kind of match the naming for GL text image 2D. So if that's the case, then here, after we bind, we could just call allocate texture, and we can pass it what we want. So here's a texture ID. So I don't even need to bind it actually, now I think about it. The width and height. The internal format will be this. Yeah, there's internal format and then format, which are not quite the same. It's a bit confusing. I always found this API to be a little confusing. You have internal format and you have format. So internal format specifies the number of color components in the texture. It must be one of the base internal formats given in table 1, one of the sized internal formats given in table 2, or one of the compressed internal formats given in table 3. And then format specifies the format of the pixel data. which is different from specifies the number of color components in the texture. Specifies the format. Okay, so this is the input pixel data. So saying here is the, okay, so that's for, right, I see. Okay, so I guess what we can do is we can expose that as well. This is kind of like the form, they call it internal format, but it's the format of the texture itself on the card, and it will have a glint, because that's what everything's a glint, right? Yeah, no, glenum in this case. Format. I can say pixels format. How about that? Slightly more clear. So then over here, we'll say, yeah, that's the format we want on the card, followed by the pixel format for this guy, which is going to be the same thing actually. And then the pixels, which is image data, data get. So then all of this is useless now. And then load texture data is basically the same thing, so I actually don't really need this function because it's the same as this one. Okay, allocate does not take one. Right, so now we're gonna feed the what we want here. So the internal format will be RGBA. Let's store it as also RGBA on the card. Oh no, sorry, on the card it'll be RGBA. The source pixel format is also the same. And here's empty texture. Okay, like that. So here we're actually going to say on the card we want it to be the float version that we had. So what was that again? That. In the pixel format itself, well, we will have no... Okay, so what if we don't have pixels? Yeah, what does it mean if you don't have pixels? Does this field mean nothing? I suppose. In which case, I guess I'll do this. So I do like a little bit more now. We see that we're allocating a float, 32-bit float, a float per channel buffer here. Oh, did not like this. Okay, it's got something to do with my buffer here. So it's a byte buffer was supposed to have 64 by 64 by 4 bytes per pixel, which should be the red, green, blue, and alpha. And that looks right. The format determines the composition of each element in data. It can assume one of these symbolic values. So we're using RGBA. Each element contains all 4 components. Each component is clamped to the range 0 to 1. We'll try and debug. Oh, is it? That should be equivalent though, right? Oh, now we get here. Okay, just to be sure, if I just make this really big, although that might blow my stack. Yeah, stack overflow. Let's do let's say to include std vector. Nope. Okay. Okay. See, this time it did what I expected. So it's my size that looks like it's wrong. Why is that wrong? What am I missing here? Yeah, so now I'm getting the same error. 64, about 64 by 4. What is it I'm missing? It's 4 bytes per component, right? 16K. They're packed next to each other. Unpack alignment. Specifies the alignment requirements for the start of each pixel row in memory. Unpack. Specifies the alignment requirement for start. The allowable values are 1 by 2. Unpack alignment. Okay, that looks correct. I don't know. Oh wait, that's not right. The type here is wrong. This has to be GL byte, right? In the case, unsigned byte, right? Okay. That's it. That's what I'm missing. Right, because the format is just like what the color, how the colors are distributed in order, and then the type is what is the type of each one of those. So actually the fact that I was putting GL float there, since this is really referring to the format of pixels, it didn't make sense even to put float in the case of the buffer that we're loading from right now. Where is it? Like when we allocate a texture for our float buffers here, we don't even have any source pixels, so we don't really care what it's set to. So what I mean is if I put this as GL unsigned byte, like over here, in the current situation it should work. I think. Yeah, it looks like it's working the same way. Because I'm basically not loading a source image here. So you know what, I'm gonna do this a bit different. I'm gonna do like this. And then it's a GLNU as well? I think it is. Type. Pixel type. I mean, I'm not a fan of default params, but this is a case where I really don't see us changing this much. And if I do find myself having to mess around with these, we'll find a better way. What I might create is some kind of triple of, you know, the pixel data along with its format and pixel type as like one unit, and you pass all that, you know. But I don't think it's worth worrying about it right now. So this is the target, and we have the pixel should be next, and I don't need this because it'll just be, oh no, yeah, this is the format of the data itself, which will also be like that. Okay. Ah. Not quite. What did I mess up here? It's weird. I mean, all I did was reorder this and add a pixel type here to GL unsigned byte. RGB. Oh, this should be RGBA. Okay, because it didn't have alpha. Let me just see what this would look like. So this is an optional parameter. You may not have any pixel data. You can say I guess it wouldn't be a value or because it's a struct, right? We could do something like this. You know, I can say auto pixel data is equal to, or we can say like value or, so if it has a value, great. Otherwise, what we will do is we'll take one that takes a null pointer, and we don't really care too much, right? We'll just say whatever. Because they don't actually matter. I think that makes sense. I need to put pixel data here. So if a value was passed in, that's what we get. Otherwise, we'll create a pixel data that looks like that. And then here we can say pd.format pd.type. In fact, type. It should be arrow, I think. No, dot, yeah. Auto ref even. Const auto ref. We can do it by value, it's okay. pd.pixels. Now, I think it's going to be a bit more clear when we do want to pass data here. And you know what? Let's, yeah. We'll go like this. Pixel data. This, and we will pass the this API is more clear. Basically, when we allocate a texture, we must pass this stuff here, and then optionally we can pass in pixel data, where we say, here's the actual pixels, here's the format of it, and here is the type of each pixel. So here's a case where we would do want to put pixel data. And then here are cases where we don't want to pass pixel data, so this will remain the optional case. Let's see if this works. Something it doesn't like here. Conversion from int to GL enum requires a narrowing conversion. Did I make a mistake here? Where's my int to GL enum? Oh, did I make a mistake? It's not GL enum for the format. No, it is. It's really on this line. Is it not calling format off? No, it's like this. Interesting. It's because when you use what do you call them? The universal initializer, whatever it's called, uniform initializer, it does not allow for narrowing conversions, which is what's happening here. This here is an integer value. It's not actually an enum value, but we're assigning it to an enum, and so there is an implicit conversion that's expected here, but that's fine in the old C API with parens. But it doesn't work this way unless we provide a constructor here that takes all three. Still doesn't like it. Is it? I guess because I'm still using that. But if I make it a proper constructor call, oops, then it won't care, right? Yeah, that's interesting. So why did he complain about the other usage, like here? That's still doing the same thing, right? Like, what's the difference? So now it says element 2 because there's actually a constructor. Or is it talking about the second element here? Oh, because this is an expression? Ah. Okay, right. Oh, that kind of sucks. Okay, if I say gl enum here, this will be fine. I can go back to being constructorless, right? So yeah, basically because this is an expression, I guess, with this ternary operator, the type of the expression for some reason ends up being an int. And I suppose that I guess that's one of those two levels of conversion. We're not binding this directly to the value in the struct, but we're binding the result of an expression. And so that somehow doesn't work. I'm not quite sure. Anyhow, so this should work. Okay, so this is working. What this is the case where we don't have, like, the overlay is not found. This is here, failed to load overlay. Overlay is mine.png, right? And if we put it back, we just rename our folder back to overlays. There it is. So we're happy again. Alright, a little bit more refactoring, starting to look a bit cleaner. Load PNG is a very small function. We're not duplicating code anymore. And I like that we're using std optional again here. This is really nice, you know? It's really cool to be able to have a real optional parameter like this, to be able to use value or, just makes it so much cleaner. Loving these C++ 17 editions. A lot of these functions should be moved to like a GL. I'll probably have like a GL helpers thing soon, or GL utils. Just like I have image file utils, I'll have some GL utils. A lot of these just belong in there. But it's okay. Oh, and I still have this. Okay, actually let's now see if this really works with our properly sized stack buffer, which is probably too big anyway. Okay, this works. Good. Yeah, I don't know, I might Stack Overflow here by doing this. I'm not yet, but probably I should be doing it this way instead. And this will default initialize. Because it'll value initialize, so it'll get all zeros. We actually have to try like this. So it has to fail for it to go through there. Perfect. Okay, I think I prefer this because we don't want to run out of stack here. So if we fail, then make the overlay texture an empty, like a 0. Then allocate a 0 alpha texture, a min-sized texture, so that it's so. Alright, min-size transparent texture. There we go. Alright, I'm going to just commit this and I'm going to call it quits for the night. It is already midnight. Okay. All right, so fix black screen when overlay is not found. If overlay is not found, we create a transparent min-sized texture. Okay, and actually at this point I don't think I need this overlays branch. I'm pretty happy with this. Or at least I'll just merge it into master here. Yeah, we'll just fast forward. I don't really care. It's fine. I think, will I keep working on overlays? Okay, I'm not sure. Alright guys, so thanks for hanging out, and if all goes well I should be streaming again as usual on Wednesday. We'll see, but yeah, if you want to know, just follow me here on Twitch or on Twitter, and I always tweet out and write on Twitch whether or not I'll be streaming, so hope to see you guys on Wednesday night, and thanks for listening.